Welcome to the Research Experience for Teachers, RET, Summer 2016.
I'm John D'Alessandro. I'm a physics teacher at St. Xavier High School. I've been teaching for 22 years.
And I'm Mike Day. I'm a math and engineering teacher at Reading High School, and I've been teaching for 28 years.
This is graphene and micro-supercapacitors.
And how they can save the world.
The Project 2 team would like to know, does your mobile device run out of energy at the worst times?
Are batteries the answer? I don't think so. Micro-supercapacitors made from graphene to the rescue.
How did we make the graphene? We started with a nickel polymer slurry. We heated it at 1,000 degrees Celsius, adding gases, specifically methane gas. We rinsed it in hydrochloric acid, and that left us with pristine graphene. Notice that we used three-dimensional graphene. This is a scanning electron microscope image. It looks like crumpled up sheets of paper. That's incredibly important.
So how did we make micro-supercapacitors with the graphene? First, we etched the graphene using a really cool laser. We added electrolyte to improve the capacitance, and then we added copper to help with our testing.
What did we do to make the micro-supercapacitors better? Well, we did two tasks. The first one,
we laser cut the graphene with an interdigitated pattern. Notice it's only 25 microns inside each channel. That's less than half the size of a human hair.
Were we successful?
One of our first samples, the laser was too strong and deformed the pattern. In another sample, the laser was not strong enough to cut through. This was one of our best samples. So the answer is yes and no.
This is cyclic voltammetry graph. Notice that this area inside the curve represents the amount of energy stored by the supercapacitor. We were definitely getting energy stored in some of our components, so yes, we were successful, but not always.
What was our task 2, you might say? We added electrolyte to the graphene, specifically polyvinyl alcohol and
a MIMBIF-4.
John, do you know what a MIMBIF-4 stands for?
Yes, I do.
Were we successful applying the electrolyte?
Notice that the PVA did in fact produce a good energy curve. However, the MIMBIF-4, a dramatically better energy curve. Notice one of the main reasons we wanted to try the MIMBIF-4 was so that we could use much higher potential differences. That's the width. It also gave us a lot more area inside the curve.
These tasks have never been done before.
So how does the research apply to our teaching units? Well, for my unit, I'm going to have my students build toy electric cars with power supplies. They're going to use the engineering design process to refine their cars, and their main constraint's going to be timing.
And for my unit, energy wasn't good for. Since we did research on capacitors and make them better, they're going to build their own capacitors. They have to charge it quickly and discharge it slowly while running a fan. They will use the engineering design process to implement it, test it, and refine it. But they only have $5 to do it. We would like to thank the RET and the National Science Foundation for this opportunity to be in this awesome program.